Hello everyone, it's Mr. Duffy. Welcome to physics. Today we're going to be taking, our lesson is going to be about basic trigonometry that we'll use in physics. So this is going to take you back to your geometry class, in which case, again, we're learning about finding different sides of triangles and finding different angles possibly given sides, or if you give it like an angle and a side, how to solve for the missing piece, what we want to know. So let's go ahead and get started, but the need for trigonometry in physics is in last unit we didn't really need it because we were dealing with things that go from one place to another in a straight line. But now we're going to be talking about in this unit about two-dimensional physics, in which case things move maybe vertically and horizontally at the same time, or again we could say like in direction systems, which we'll use a lot, northeast, maybe it goes northeast. So that is going to become important when we're in physics for this next unit. Now, what we're going to start off with is pretty simple, just basic angles. So an angle is basically we have two lines and they meet at a particular point. And an angle is the measure of, degrees between them, like the portion of the circle that it encompasses. So again, it's just a measure between those two different lines. We're not going to need to know how to use a protractor, but again, you could use a protractor to, again, solve for that angle. Now, most of the time, an angle is going to be given to you in a problem, or maybe it's going to be a story problem and you have to interpret what that angle is. But sometimes they'll say they're positive angles or negative angles. Now, in math, you might not have much, in common with that. Maybe it was never covered, but in physics, that is a way to denote angles. Basically, again, we're starting from the positive x-axis, and a positive angle would be measured counterclockwise from that. So again, starting on the positive x-axis, you move around counterclockwise, and again, that could be 90 degrees, 105 degrees, 270 degrees. Those are all count, but again, they're measured from the positive x-axis. And then another way to denote it is a negative angle. So let's again say I have a positive 270 degrees. Okay, that's measured again from the positive x-axis. But I could also say a negative 90 degrees, and that would be the same exact thing. So again, it's just a different measurement. Negative angles are measured clockwise, and positive angles are measured counterclockwise. We will use that sometimes, but it's not as common. It's not as common of a denotation for physics class. What we'll more commonly use is a quadrant system, but not quadrants 1, 2, 3, and 4 necessarily like you might be familiar with in like math, but more of a north-south, east-west type of quadrant system. Somebody's going to go, again, northwest or southeast. Those are the directions we'll be using more often in physics. So let me give you an example of that. Let's say somebody's moving in quadrant 3. Let's just say pretty much at a, I guess let's say a 45-degree angle. But how do we denote that instead of, again, saying quadrant 3? What would that be? Negative 205 degrees, or anyways, how would we denote that using north, south, east, and west? Well, in physics, what we would say is we would say 45 degrees south of west, because it's 45 degrees if I south of west. So if I start with west and I go 45 degrees south of that, that would be where that line is represented. Another equivalent way of saying it would be if I'm going 45 degrees west of south. Those are, again, equal ways of saying that same line, that same angle measurement. And you'll see both of those, again, you'll see that in a lot of your physics problems. There's different ways you can say angles. Now, we're always going to use degrees versus radians. I know that you might be familiar with radians from your math class, but again, we're always going to be using degrees. Degrees, again, just measures the portion of a circle that, in angle measures. And there's 360 degrees in a full circle. Now, again, radians is another way to measure portions of a circle, but we will not use that. And there is a conversion to go between the two, but again, we're just going to stick with degrees for this whole unit. Now, what we need to be familiar with when we're making measurements is not only angles, but a lot of the times we're going to be using right triangles in a lot of our problems. And that's going to amount to some terms that you need to be familiar with when we're talking about right triangles. Start off with the hypotenuse. Again, you're probably familiar with these, but the hypotenuse is always the side that is opposite of the right angle. Then the other sides, the opposite and adjacent side, really depend what your reference angle is. So I'm just going to use reference angle A here. And the opposite side is the one that is opposite angle A. And the adjacent side is the one that is next to it. So again, if your reference angle was the other angle, then those would be different. It really, again, you have to denote a reference angle to say what is opposite and what is adjacent. Now again, right triangles in physics, ramps are right triangles, ladders propped up against a wall are right triangles. So we're going to have to, solve for different maybe lengths they're moving or the height of the ramp, So right triangles are going to become important. A lot of the times also, we're going to have to find the right triangle. So for example, if I got this pendulum here on the left, and now I made myself a right triangle, I might want to know like how high that pendulum was raised before it was like let go maybe. And so again, right triangles would allow me to solve that. If I have gravity is pulling the box down this ramp. But again, I might want to make a right triangle with that to figure out how much is going down the ramp and how much is going into the ramp. Again, when we're talking about maybe like friction, maybe that box is stationary and so friction is holding it on the ramp, or maybe it's starting to slide, who knows. But again, a right triangle is going to allow me to solve that problem. Maybe I want to know how high the angle of elevation for a star in the sky. Again, a right triangle is going to allow me to do that. So right triangles will come into a lot of the story problems, a lot of the problems we're going to do in physics. So we need to know how to, again, solve for those right triangles. To do that, that brings up 4 new equations for this unit, but I don't think they'll be new to you guys. Those are our right triangle, SOHCAHTOA, sine, cosine, and tangent, and then we have the Pythagorean theorem, a squared plus b squared equals c squared. So sine of a angle would be the opposite over the hypotenuse, cosine is adjacent over the hypotenuse, and tangent is opposite over adjacent. So the abbreviation SOHCAHTOA, you're probably familiar with that as well, allows you to, again, find or remember which one is which and which one to use when you need to use it. And the Pythagorean theorem, again, a squared plus b squared allows you to find the missing side. Again, if you're missing a or b or c, you can find it. So let's take a look at that. I've got a practice triangle for you. And what I want you to do, again, I've got the 3 different sides already given to you. I just want you to kind of, again, using the different reference angles, reference angle A and reference angle B, I want you to try and solve for what values sine, cosine, and tangent would be. I would like you to pause the video, take a second to maybe do these on your own, or think about them at least, and then unpause the video and see if you were correct. Okay, hopefully you can pause the video, but we'll go over the answers right now. So sine of angle A would be the opposite over the hypotenuse. So opposite is 12 over the hypotenuse, which is 13. Cosine is adjacent over hypotenuse, and the adjacent is 5, and the hypotenuse is 13. And tangent of angle A is opposite over adjacent, so that'd be 12 over 5. So that is angle A reference. Angle B, on the other hand, sine is opposite over hypotenuse, so that'd be 5 over 13. Cosine of angle B would be adjacent, so that'd be 12 over 13. And tangent, opposite over adjacent, would be 5 over 12. So those are the answers. Again, just if they give you all 3 sides, it's not super likely they would give you all 3 sides in a triangle. But again, this was an example problem. Next one we've got is more, again, realistic. Given an angle and one side of a right triangle, find all the missing sides and the missing angles. Okay, so we have triangle ABC. It's a right triangle. It doesn't show you which is the right angle, but we can tell from looking at it. Angle C would be the right angle. Oh, it says it in the problem. Angle C is the right angle. The measure of angle B is 20. Side A is 6 centimeters. I'm going to say side AC. That's got to be the 6 centimeter one. And then the measure of angle B is 20. Okay, so now we have to find the missing angles, missing sides. The first thing I think would be easy to do is just find the missing angle. We know that all angles in a triangle add up to 180 degrees. We know we've got a 90-degree angle and a 20-degree angle, so that must mean that we have a 7-degree angle right there. So angle A is a 70-degree angle. Now we found all the angles in the triangle. So now we need to find the two sides, side BC and side AB. You could do this again in a variety of ways. What I'm going to do is I'm going to use angle A, and I'm going to use tangent. So I'm going to do tangent of 70 degrees equals my opposite, which will be, I'll call side X, I guess. X over my adjacent side, which should be 6. Now plug that into my calculator. Tangent of 70 times 6. That gives me a side of 16.5 centimeters. Okay, so that's side, again, BC. Now, from here, again, I could choose to use maybe, sine or cosine, but I'm going to use the Pythagorean theorem just, again, for practice of that. I have my A side and my B side, so 6 squared plus 16.5 squared equals my hypotenuse squared, which, again, that would be C, my hypotenuse. So go ahead and, again, type that in my calculator, plus 36. Don't forget to take the square root of it. And we get side C as equaling 17.5 centimeters. Okay, so again, using different trigonometry functions to solve for missing values. Give me 1 second here. We'll move on to the next slide. I don't really know how to do a clear all in Cami right now, so. Okay, now one thing that you guys are going to want to know how to do is, again, if you're using a TI calculator, you need to make sure that your computer is in degree mode, not radian mode. And I know that that's not really going to be too much of a problem necessarily, but when it becomes a problem actually is when you are in math class where you're using radians, and then you come to physics class and we're using degrees. You really got to make sure you switch it back. And I will try and remind you, but you got to make sure you're in degree mode when you're doing these problems. So inverse sine trig functions allow you to, again, solve for the missing angles, and that's what we're going to practice next. So I've got 3 different problems here, and again, I want you to pause it, try these different trig functions, in which case we're doing the inverse sines or inverse cosine or inverse tangent, in which case we're solving for the angle in each of these problems. Again, pause the video, see if you can, again, figure out each one of these on your own, and then unpause it and I'll go over the answers. Okay, so now we're back. The first answer comes out to be 14 degrees. I'm just going to round to a whole number. The second answer comes out to be 37.6 degrees. And the last answer comes out to be 36.9 degrees. Okay, so those are inverse trig functions finding the different angles. Let's put it to practice in a triangle. So we want to find angle A and we want to find angle B. Now, honestly, once we find one, we could find the other, because again, once we know that they the angles add up to 180 degrees. So again, when that's the case, we can definitely solve for it. But let's go ahead and solve angle A here. We have our opposite side and our hypotenuse. So that would mean we would have to do sine. So we've got sine of theta, which is, we'll just say angle A, is my opposite, which is 15 over 17. So now I have to do inverse sine, 15 divided by 17, and I get an angle of, say, 62 degrees. Now, I again know that my other angle is 90 degrees, and this one's 62, so I could definitely add them up to 180 and solve for it, but I'm just going to do it using trig functions again. And so I'm going to solve for angle B there. I would now have my adjacent side and my hypotenuse given to me, so that would be cosine. Cosine of angle B, I'll just say angle B there, equals my adjacent, which is 15 over 17. So inverse cosine of 15 divided by 17, and I get 28 degrees. And again, that's what it should have came out to if I did it the other way as well. And now I have my two different angles. So again, this is just an introductory lesson into trigonometry. Again, just a refresher on it because we will use trigonometry so much in the next couple chapters. But hopefully it makes sense to you. Hopefully it's, again, not new material. And thank you for watching.